for alternating series. I would like to use the alternating series test to decide whether the series is converge or diverge. All right, so starting with the first one. The first one, how do you know this is an alternating series? Do you see that there is a -1 raised to some power? That is a clear sign of alternating series. So first of all, number three, what is Bn? So Bn is the one with a -1, right? So that is e to the 2 divided by n, and then the bn plus 1, which is the next term, that is e divided by 2, e raised to 2 divided by n plus 1. So number one, we want to show that the current term is greater than or equal to the next term. So therefore, we have to do some tests. When n is equals to 1, we have b2 that is equals to e raised to the 2 divided by 2, and then this is b1 is equals to e to the raised to the 2 divided by 1. So this is a e to the first, and then this is a e square. So we just showed that the current term is greater than or equal to the next term. So if you look at the alternating series test, number one, this is the first condition. Number one is satisfied. What about number two? Number two, we want to show that limit as n approaches to infinity of Bn is equals to 0, right? So we want to show this. So limit as n approaches to infinity, e to the 2 divided by n, so that is e to the raised to the 2 divided by infinity, which is e raised to the 0 power, that is equals to 0. Is that true? Is e raised to the 0 power equals to 0? The answer is no. Any non-zero raised to the 0 power is equals to 1. Unfortunately, that is not equal to 0. That means condition number 2 is not satisfied. Not satisfied. What does that mean? So you are thinking about the alternating series, right? A1, A2, A3, A4. If you look all the way to the right, these terms, they are not equal to 0. They are not even close to 0. Not even close to 0. That means when you add them up, these not equals to 0. With this, when you add them up, the sum is going to be equals to a positive infinity, which makes the series divergent. So since number 2 is failed, then we say that the series is divergent. Because number 2 is failed. Either one of these fail, then the whole series is divergent. All right, let's take a look at number 4. Let's switch color for number 4. So since you don't see the problem anymore, now is a good time to take a screenshot right there, because we still have 3 problems to go. All right, did you get your screenshot? Number 4, there is no -1 raised to some power. How do you know that that is an alternating series? Let me tell you right now. Number 4, we have the summation from 0 to positive infinity. We have a sign of n plus 1/2, and then times pi. The denominator is 1 plus the square root of pi. So what is the graph of sine? The graph of sine is alternating between +1 and -1, right? So thus we can say the sine alternates between -1 and 1. Between -1 and 1. Okay, so that means this is an alternating series. Okay, what is my Bn? My Bn is pi divided by 1 plus pi. 1 plus the square root of n, not pi. And then the Bn plus 1, that is equals to... Oh, actually, do we really need the pi? I don't think we will need the pi, because the pi is just a constant. All right, so we don't need the pi. Then we will change the pi to a 1 then. Then the n plus 1 will be 1 divided by 1 plus the square root of n plus 1. So when n is equals to 1, what do you get for B2? B2 is 1 divided by 1 plus the square root of 1 plus 1, and then B1 is equals to 1 divided by 1 plus 1. So this is 1/2, which is 0.5. If you approximate the B2 is about 0.47. Now, we just proved that the current term is greater than or equal to the next term. So number 1 is satisfied. We put a check mark in there. And then number 2, you want to show that the limit as n approaches to 0, bn 1 divided by 1 plus the square root of n is equals to 0. Is that true? The answer is yes, because you will have 1 divided by 1 plus infinity, that is 1 divided by infinity, that is equals to 0. So number 2 is also satisfied. According to the alternating series test, the series is convergent. So that would be number 4. And then let's move on to number 5. Let's switch another color for number 5. So number 5, we have the sum. N goes from 1 to infinity, and then we have negative 1 raised to the nth power, and then sine of pi divided by n. So the negative 1 raised to the n proves that this is an alternating series, right? So that means we have to work on the sign then. So the Bn is equals to sine pi divided by n, and then the n plus 1, you just change the n to an n plus 1. Pi divided by n plus 1. Okay, let's do some proof, because I want to show that this is true. Okay, when n is equals to 1, what do we have? B2, then this is sine of pi divided by 2, right? And then this B1 is sine of pi. So what is sine of pi? Do you still remember your unit circle? Sine of pi is equals to 0. Sine pi over 2, 90 degrees. The y value is equals to 1. So can we say 0 is greater than 1? Is this true? The answer is no. This is not true, but we are not going to be panicked. So this is not true. This is not true. This is not true yet, right? Oh, actually, you know what? I would just say when n equals to 1, these two are not true. So when n is equals to 1, not true and not true. So when this is not true, then you have to try what happened when n is equals to 2. If n equals to 2 is fail, try n equals to 3. If 1, 2, 3, they are all fail, then I don't think the first condition will be satisfied. So when n is equals to 2, we have b2 plus 1, and then this will be a sine pi divided by 2 plus 1 is 3 versus b2, which is sine of pi divided by 2. So sine pi divided by 2 is 1, right? Y is equals to 1, so pi over 3, sine of pi over 3 is root 3 over 2. That is approximately equals to 0.86. Now we just show that B2 is greater than or equals to B3. Then number 1 is satisfied. Right here, number 1 is satisfied. Now we are moving on to B2. If not B2. Now we are moving on to condition number 2. If condition number 2 is failed, then the series is convergent. So condition number 2, we have to prove that the limit as n approaches to infinity of Bn is equals to 0. So we have sine of pi divided by n. So as n approaches to infinity, we have a sine pi divided by infinity, 3.14 divided by infinity is equals to 0. What is sine of 0? Sine of 0 is at the origin. Y is equals to 0. So number 2 is satisfied. Number 1 is satisfied. Therefore, the series is convergent because both 1 and 2 are satisfied. Okay, so moving on to number 6. So number 6, this time we have to work with factorial. I like this problem a lot. So number 6, we have a sum. N goes from 1 to infinity. Negative 1 raised to the n power. So that is a characteristic of alternating series. N raised to the n divided by n factorial. If you don't remember what factorial is, you should know what factorial is. You are taking a calculus class. So let's say a 5 factorial that is equals to 5 times 4 times 3 times 3 times 2 times 1. Do not multiply 0. Once you multiply 0, the whole thing is equals to 0. So we start at 5, and then the next factor is a decrement of 5. The decrement is equals to 1. 5, 4, 3, 2, 1. If you have a 10, then that will be 10, 9, 8, 7, 6, and then all the way to 3, 2, and 1. So that's how the factorial works. And then this one, my Bn, is equals to n raised to the n divided by n factorial. And then the Bn plus 1 is n plus 1 raised to n plus 1 divided by n plus 1 factorial looks very complicated. Let's try what happened when n is equals to 1. So we have b2, then this will be a 2 raised to the second power, and then 3 factorial, and then b1 is a 1 raised to the first power divided by 1 factorial. Oh, there is for factorial, there is a special case. 0 factorial is equals to 1, but you don't need to use that special case in here. So this is equals to 1, and then this is a 4 divided by 6. So 4 divided by 6 is definitely less than or equal to 1. So basically number 1 is satisfied. Checked. And then what about number 2? You have to prove that the limit of Bn is equals to 0. So that will be n raised to the n divided by n factorial. You have to show that this is equals to 0. If you cannot, then the series is divergent. Can you do that? This is the reason why I bring this up. How do you deal with a factorial? So first of all, n raised to the n, can you expand that for me? N raised to the n is just n times n times n times n times a bunch of n, right? Just keep on moving. N times itself n times. And then factorial is n factorial. In general, the decrement by 1 is n minus 1, and then n minus 2, and then n minus 3, and then n minus 4, so on and so forth. All right? And then how do you simplify this? So first of all, I see that this n got cancelled. Now, tell me, in order for this to be a 0, the denominator has to be greater than the numerator, right? Is this true in this case? You are thinking, right? So let me give you an easier thought. So let's say n is equals to 10. So let's do this in another color. So let's say n is equals to 10, just for example. Just for example. And then the top will be a bunch of 10 multiplied together, right? What about the denominator? The first 10 is gone because the n just got cancelled. And then you have an n minus 1, which is a 9, and then 8, and then a 7, and then a 5, 4, so on and so forth. Now, top bigger or the bottom is bigger? So this time the top, the numerator, is greater than the denominator. The top is greater than the bottom. Okay, so the top is greater than the bottom. You have a big number divided by a smaller number. Are you able to reach to 0? Just like this. Let's say this divided by this. Is that approaches to 0? Is that going to be close to 0? The answer is no. That is not true. But if you have this on the other side, that will be close to 0. So since the top is greater than the bottom, that means we want to say that the limit is not going to be equal to 0. It's not even close because the top is so much greater than the denominator. So the limit is not going to be equal to 0. Then number 2 is not satisfied. Since number 2 is not satisfied, then the entire series is divergent. Okay, so that is the end of this problem, and that is also the end of this video. What do you think? Let me know in the comment section below. If you think my instruction is helpful, please like the video, subscribe to my channel, and share the video for me. I want more people get benefits from my instruction. Alright, so that is the end of this video. I will see you all in the next lesson. Signing out.